Welcome back to the exam preparation video series for DP-100, Designing and Implementing a Data Science Solution on Azure. I'm Aravind Sridharan, a Microsoft Technical Trainer. This is the fourth and last episode in this series. In this episode, we'll focus on optimizing large language models for AI applications. We'll cover how to prepare for model optimization, optimize for prompt engineering and prompt flow, and optimize through retrieval augmented generation, RAG for short. Here's a list of the different skills you may be tested on. These skills are sometimes referred to as may include, meaning they may or may not be on your exam. This list isn't exhaustive, and while we won't be covering every skill in this video, be sure to be able to perform these skills before taking the exam. You can expect to see code-based questions that come from this function group. This exam is developed to test data scientists, which means you're expected to be familiar with the Azure AI Foundry and the Python SDK. Be aware of the model catalog in the Azure Foundry portal, which is the centralized hub to discover and use a wide range of models for building generative AI applications. It features hundreds of models across different model providers. Know that to filter the models based on your needs and metrics, you can filter models based on a provider of your choice, like Azure OpenAI. To deploy the model, it can be done in one of two ways, via managed compute and serverless APIs. Managed compute allows you to seamlessly build on top of Azure Machine Learning across a different large language model operations. Serverless APIs, on the other hand, offers a pay-per-token billing model to consume the models as APIs rather than hosting them on your subscription. Remember that Azure AI Foundry supports model benchmarking for select models, and they are popular and frequently used. Benchmarking helps you assess model performance across various metrics, making it easier to compare and select the best model for your needs. Access the AI Foundry model catalog and navigate to the AI Foundry model catalog. View the benchmarking results. Each benchmarked model includes detailed performance metrics such as accuracy, F1 score, and latency. Compare these metrics to understand the strengths and weaknesses of each model. Filter and sort the models. Use specific filters to narrow down models based on specific criteria such as model type or performance metrics. Sort the models to easily find the best performing ones according to your needs, and then select and deploy the model. After comparing the models, choose the one that best fits your requirements. Then deploy the selected model directly from the catalog, leveraging its benchmarking insights to make an informed decision. Know that you can test a deployed language model in Azure AI Foundry Playground. You should know how to tweak system messages to get an LLM to follow your instructions, and be able to change the settings like temperature to change the LLM's outputs in different ways. Some steps to perform to do this are to access the Playground, navigate to the AI Foundry, and select the Playground environment. You can then choose the language model you want to test from the list of available models, then select and send and run the model, and analyze the results. Review the output generated by the model. Know how to adapt LLMs to suit specific tasks or a domain. Apply prompt engineering via clear instructions through good system messages. Use retrieval augmented generation, RAG, by grounding your LLM to relevant data sources. Use RAG when you have specific information you want your model to use. For more consistency, you can apply fine-tuning as a method. Fine-tuning is great when you want to change the underlying behavior of your model. Make sure that you understand how to test prompts with manual evaluations. Recall the steps to test prompts in AI Foundry. Select manual evaluation and add test data via manual entry or through importing data via CSV or JSON file. Generate the results by clicking Run and evaluating up to 50 input rows and compile the results. Rate your model responses and adjust and reevaluate those prompts. Finally, save your results. Understand that creating variants helps enhance the quality of the AI model outputs by testing different prompt configurations. This saves time and boosts your productivity. It is important to allow easy comparisons to find the most effective variants. The steps to tune prompts are: create variants. Make sure you know how to create multiple variants of your prompt to explore different configurations. Run the variants. Run all the variants in a single row of data and remember to check the outputs. Then evaluate and visualize your variants. Visualize the results of to easily compare the effectiveness of each variant. Remember that the prompt tool has templates for creating prompts. To use prompt templates, you have to install the Azure AI Inference package, render a prompt from an inline string, pass the messages to the completion call, load the prompts to a prompty file, and load the model, name, and parameters to the prompty file. Prompt flow can be enabled via SDK or CLI. This is a relatively new feature that you should be aware of. It empowers developers to use code to manage credentials, initialize flows, develop flows, and execute batch testing and evaluation of prompt flows locally. Create a new flow by selecting Create on the prompt flow page. Then start the compute section and author the flow by configuring the inputs and outputs of the flow. Add tools like LLMs and Python as necessary. Test the flow by running individual nodes or the entire flow. It is important to understand tracing. Tracing allows you to analyze and monitor the execution flow of your application, which is crucial for debugging intricate applications. Some key features include enhanced observability, user-centric design, user-defined functions, secure data handling, and feedback logging. Know that cleaning involves transforming the unstructured data into a format that can be effectively utilized by the RAG application. Know that after parsing the raw data into a more structured format, the next step is to break it down into smaller, manageable units called chunks. Segmenting large documents into smaller, semantically concentrated chunks ensures that retrieved data fits within the LLM's context, while minimizing the inclusion of distracting or irrelevant information. Remember to consider the following factors when chunking your data: the chunk size, the chunking strategy, such as splitting by sentence or by specific characters, semantic coherence, which aims to create chunks with preserved context, and metadata. The next step is to convert the text chunks into vector representation using an embedding model. An embedding model is used to convert each text chunk into a vector representation that captures its semantic meaning. When selecting an embedding model, remember to consider the model choice, the max token limit, the model size, and fine-tuning. For RAG to work, we need a vector store. A vector store in Azure AI Foundry is a specialized database designed to store and manage vector embeddings, which are numerical representations of data. These embeddings are used in various AI applications, such as search and retrieval, to improve the accuracy and relevance of results. In the example displayed on the screen, the fields have specific data types. One must know how to create a search index. You must define the schema, configure the field definitions, and finally use a search client that can send the request and update indexes as needed. It is important to evaluate your model's responses. You'll be tested on the following terminology: groundedness, which measures if the response is based entirely on the provided context, avoiding hallucinations. Completedness assesses whether the response addresses all parts of the query. Utilization evaluates how much of the response is derived from the context chunks. And relevance, which determines how pertinent the response is to the query. To understand how to prepare your data for fine-tuning, these are the following factors that matter. Quality of data. This is important. Ensure high quality of data. Fine-tuning relies on well-prepared data and relevant data. Make sure you know how to provide clean and accurate training examples. Data quantity. Provide enough data. Be aware that hundreds or even thousands of examples are recommended for effective fine-tuning. Labeling data. Properly label your data to match the specific tests. Select the right models and use the relevant examples to tailor the model to your use case. Although Azure AI Foundry Portal provides you with the descriptions for each foundation model in the model catalog, you can also find more information about each model through the respective model card. To select the base model, you can filter available models based on tasks, capabilities, and limitations. Fine-tuning in Azure OpenAI is a new feature. Be sure to know how and understand fine-tuning workflows in Azure AI Foundry. Prepare your dataset. Format your dataset as JSON-L files with prompt and completion pairs. Ensure that the data is clean, diverse, and relevant to your use case. Upload the training data to Azure Storage. Store your dataset securely in Azure Blob Storage. And configure task parameters and train your model and review the metrics and evaluate the model, and then finally use the fine-tuned model. Once a model has been fine-tuned, the resulting model is evaluated for potentially harmful responses and uses Azure's built-in risk and safety metrics. The evaluation capability simulates a conversation with a fine-tuned model to assess the ability for potential harm. Models can be deployed after they clear a certain threshold to be able to be deployed and used by other end users. To recap, in this episode we discussed how to prepare for model optimization, optimize through prompt engineering and prompt flow, optimize via retrieval augmented generation, and optimize through fine-tuning. Remember, this group accounts for 10 to 15% of the exam, so keep that in mind when preparing for the exam. Thank you for watching the DP-100 Designing and Implementing a Data Science Solution on Azure Exam Prep video series. We hope that this series helped you understand the skills that you're strong in and the areas you might need to revisit. Remember that understanding these concepts is crucial for your success. Be sure to leverage other exam prep resources such as the study guide, practice assessments, and exam sandboxes. On behalf of all of us at Microsoft, good luck to you on your exam. For more information, you can visit aka.ms DP100 exam.